So we left off in the middle of the section. We were talking about logarithmic functions. There are a couple things that we have not done with logarithms yet, and one of them is expanding or combining logarithms. So we've done it a little bit, but not to the extent that you really need to know it for pre-calc and beyond. Yes? Oh, did I not do 7 and 8 yet for your class? Or 6? Oh, man, so we'll start there. All right, so number 6, we have log base 5 of 1 over the square root of 125. Okay, so when we think about the square root of 125, notice it's on the denominator, so I'm going to rewrite it first as log base 5 of 125 to the negative 1/2. The negative means it's on the denominator, the 1/2 means it's under a square root. And when I do that, I can pull the negative 1/2 to the front. So I have negative 1/2 times log base 5 of 125. So we know that when we have logarithms, log base 5 of 125, what we're saying is 5 to some power gives us 125. So what power would that be? Everybody always says 5, every class. You're always like, 5! No, it's not 5. It is 3. 5 to 3. 5 times 5 is 25. Times another 5 gives us 125. Yes, so it's going to be 3. So I get negative 1/2 times 3. So I get negative 3 over 2. All right, so the next one, a little bit harder. What we're thinking of is 1/2 to some power gives us 1 over 16. So if you need to put in the x, that's okay. So we're saying 1/2 to some power gives us 1 over 16.
4.
It is 4. It's saying 1/2 times 1/2 times 1/2 times 1/2, right? 2 to the 4 is what gets us 16. So x is 4. So sometimes it makes a little bit more sense if you just see it. So if you need to write an x in, you can. All right, now for the super hard one. Are you up for the challenge? All right, this one. We have log base 8 of the square root of 2. So again, if you need to set it equal to x, go ahead and do that. So we have 8 to some power gives us the square root of 2. 1/3. Some people are thinking 1/3. That's very close, but 8 to the 1/3 actually only gives you 2. Yes, Emerson is actually correct. Okay, it should be 1/6. Okay, so if you do not know how to do that, this is the easiest way to do this problem. Get them to have the same base. So instead of having 8, what I'm going to do is I'm going to rewrite it as 2 to the 3. So I have 2 to the 3 raised to the x equals 2 to the, what power? 1/2, right? So I'm going to have 2 to the 3x equals 2 to the 1/2, which means that 3x has to equal 1/2. So when I divide by 3, right, dividing by 3 is the same as multiplying by 1/3, I end up getting x equals 1/6. Okay, that's probably the easiest way to think of it. So if you cannot do it in your head, like Emerson can back there, right, then you should probably write out the steps. Emerson is very smart. Emerson isn't always paying attention back there these days, but all right. So expand the logarithms in numbers 1 through 3 and combine in 4 to 6. Okay, so if I'm expanding the logarithms, what that means is I'm going to divide it up into as many logarithms as possible. So I'm going to break it apart. So I'm going to have log base 8, and I have 5 times y. So do you guys remember when we have log base something of a times b? It's really log of a plus log of b.
Yeah.
That's what we need to do. We need to break it apart. All right, so we're going to break it apart into log base 8 of 5 plus log base 8 of y. And we're going to leave it like that. I guess I shouldn't say as many logarithms as possible because, you know, you could do change of base and so on. All right, the reason we have to do that is because in calculus, we like to take the derivative of these things. It's like the slope of these functions. But it gets really, really complicated when you have it all as one compact logarithm. It's easier when you can separate them. So you'll understand what that means next year. But all right, so anyway, so if I have the natural log of something divided, remember if I have like a log of a divided by b, what's it going to be? Log of a minus log of b, right? I'm going to subtract. So here I'm going to have natural log of x squared minus the natural log of y times z cubed. All right, can we continue going? Yep. So I'm going to have natural log of x squared minus, and I'm going to break apart this natural log of y times z cubed. I'm going to break it into natural log of y plus the natural log of z cubed. And I can distribute the negative. So I get natural log of x squared minus natural log of y plus the natural log of z cubed. But the last thing that we're going to do will also make things super simple in calculus. We're going to bring, what did I do? Oh, dang it, I forgot. I said distribute the negative, and then I didn't do it. Man, I saw two people with that one. I saw Julia's hand, but I also saw someone else over here. Was it Julie?
It was Louie.
It wasn't Louie. It was someone at this table. Was Louie? Okay. So Louie and Julia. Can one of you guys write your names up there? Julia, be the representative. Write your names on the board. All right. And then the last thing that we're going to do is we're going to, I was already moving on to the next step. We're going to bring the power to the front. Okay. And like I said, it's going to make it much easier in calculus when we do this. So we're going to have 2 times natural log of x minus natural log of y. Yeah. Minus 3 times the natural log of z. Okay, and that's our answer. All right, so how about something like number 3? Woo-wee. Oh, nope, we're powering through. We're doing this. Ready or not. All right, so we're going to set it up. So we're going to have log of, we'll have the x squared. And we're also going to have plus log of the cube root of x minus 1. Do you guys see that? Because they were multiplied on top. And then we're going to have minus log of 2x minus 1. All right, so I'm going to pull the powers to the front. So the 2 definitely goes to the front. So I'm going to have 2 times log of x. What about the next one? Log of the cube root of x minus 1. It is a 1/3, exactly. So if you want to write yourself a note, this is a 1/3 power. So when we pull it to the front, we're going to have plus a 1/3 times log of x minus 1. And then the other one is log of 2x minus 1. Can I separate that at all? No, you can't. So don't get confused and think, oh, it has subtraction in between, and now I'm going to do division, right? Don't do something like that. It does not go down any further. So we're going to have log of 2x minus 1. Barely fit in there. All right, so now we're going to go the opposite direction. We're going to combine into a single logarithm. Okay, so first we're going to do the powers, right, because that was the last thing we did before. Then we're going to do the multiplication, division, or whatever. Okay, so I'm going to bring up this 1/2 up as a power. So I'm going to write it as log of 6 plus log of 9 to the 1/2 minus log of 3. What is log of 9 to the 1/2? Square root of 9, which is 3. What happened? Yeah, log of 3 and minus 3, log of 3, actually end up canceling. All right, so you end up just getting log of 6. All right, same idea on the next one. So we get natural log of 6 plus natural log of x cubed plus natural log of x squared minus 2 squared. So I'm going to have natural log of 6x cubed times x squared minus 2 squared. Do you guys see how I did that? So since it's like natural log of a plus natural log of b, we can write it as natural log of a times b. That's what I was doing. I'm just multiplying everything together. 6 times x cubed times x squared minus 2 squared. All right, and that's as far as we go. Okay, so you understand the expanding, combining, all of that. All right, next up. One more.
Yeah, wait, we go back here.
Yep, so go ahead and start the next one. So start number 6. All right, so on this one, we have log base 3 of y. We're going to bring the powers up. So this 1/2 is going to go up, and the 2 is going to go up. Did I just do this one? Is this the same one? No. Okay. So I get log base 3 of 81 to the 1/2 plus log base 3 of x minus 2 squared. Okay, so when I combine, they're all added. So that means when I combine into one logarithm, I'm going to have log of things multiplied. So I'm going to have log of y times, what's 81 to the 1/2? 9 times x minus 2 squared. All right, question. What if I had log base 3 of x plus log base 4 of y? You can't combine. So they have to have the same bases. So since those don't have the same base, you cannot combine them.
Could you do, is there any way you could have a common also make it 12?
You could do a change of base formula, but the change of base formula would still have like a denominator that would have something like that. So you could do this, I guess. But then you'd still have to get common denominators and be kind of messy. Yeah?
On last one, the answer have log base 3.
Yes, it does. Thank you. Darn. All right, so next up. So it says the AP Calculus test uses laws of logarithms constantly. So, you know, a lot of times people ask me, what should I teach in pre-calc? What should I teach in algebra 2? Blah, 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 blah. And I always tell them, like, you should teach logarithms in pre-calc. They should just get a little bit more challenging, right? Because it's really important on the AP Calc test to know, like, to be fresh on your logarithms. The thing that they do on the AP Calc test all the time is they write things in different forms. So you might get a certain answer, and you're like, oh, here's my answer. It's -1 minus 3 natural log of 2 all over 2. And then these are the answer choices. Look at those. Do any of them look anywhere near your answer? Not really. Maybe C, but it's missing that 1, right? That -1. So it's super important that you guys know how to change things around. So it's going to be a little bit weird. I'm going to show you. So if you have -1 minus 3 times natural log of 2 all over 2. If this had been a calculator portion, all you could do is you could find that decimal approximation. You could put it into your calculator and you could be like, oh, it's around this. And then you go through the answer choices and you can eliminate the ones that aren't the same, right? Does that make sense? But this was on the non-calculator portion of the test, okay? So they had a lot of trouble with this. So the first thing we're going to do is we're going to look at our answers and we're going to kind of eliminate the ones that we know it can't be. I don't think it can be C because it's missing, like if I brought the 2 into both pieces, I would have -1/2 minus 3 natural log of 2 all over 2, right? It's missing this -1/2. Do you guys understand that? I don't think it's missing C. Or I don't think it's going to be C. Okay, but I don't know about the other ones. Maybe it's simplified down. I don't know. So let's figure out what we can do. Notice how A and B have an 8E in there. That's really strange, isn't it? You could start with -1/2 times natural log of 8E, and you could break apart the natural log of 8E. How do I do that? Natural log of 8 plus the natural log of E, right? What is the natural log of E? It exists. It's 1, right? It's E to what power gives you E? It's 1. So we're kind of getting there. I don't know, maybe. But what about, like ours has a 3 natural log of 2. Well, what can we do with numbers up front?
You
You can make them as powers, right? So I have -1 minus natural log of 2 cubed all over 2. So I have -1 minus natural log of 8 all over 2. Am I almost there? We actually are. If you distribute this -1/2, you get negative natural log of 8 all over 2 minus 1/2. And if you write it like as a common, with a common denominator, it's exactly the same thing. You can see? Like, that's what can be frustrating about the AP Calc exam. Like, you get the right answer, but then you're like, wait, now I have to do all this simplification to see which one's correct. Like, this isn't the form that mine was in. Do you understand that? Okay, so it can be kind of frustrating with logarithms sometimes. All right, so the change of base formula, we kind of mentioned it a little bit ago. The change of base formula says that if you have log base B of A, you can change it to whatever base you want. The bases that are most common, right, are the ones that you can use on your calculator. So changing it to like natural log or just log base 10 is usually the best. So what we do is we do log base 10 of A over log base 10 of B. So that's one way. Or you could really use anything. You could do natural log of A over natural log of B. Or like I said, you could change it to any base that you want. So let's say we change it to a C. Okay. The thing to remember that I always say is that the A goes up and the base goes down. So the number that was like, I don't want to say bigger because it's not really like necessarily a bigger number, but the one with the larger font goes up, the subscript goes down. Does that make sense? All right, so it says use the change of base formula in common or natural logarithms to evaluate each logarithm correct to 5 decimal places. So get your calculators out. We're going to do correct at 5 decimal places. So I'm just going to change it to log base 10. So I'm going to have log of 5 over log of 8. I didn't write a base, so it is base 10 then. Let's go and do that. All right, so we're going to do 5 decimals. So we have 0.77398. Did you guys get that? All right, log base 11 of 21. It's going to be exactly. And you can test it. You could do natural log instead. If you do natural log of 21 divided by natural log of 11, you get the same thing. 1.26966. Right? Does that make sense? Okay, so why is this important? Well, you need to know how to put things into your calculator. Now, some of you guys have fancy calculators, and if you guys hit math and then go all the way down, you might have something that says log base. So you're good, right? Maybe you don't have to do the change of base. Maybe you already have it on your calculator. But you should still know how to do it. Okay, so it says use a graphing calculator to graph y equals log base 6 of x minus 1. Okay, so if I'm putting this into my calculator doesn't have log base. So I have to put this in as log of x minus 1 all over log of 6. All right, and then it says, once we do that, we're going to use the calculator to find the solutions to a very strange equation. So would you guys know how to solve an equation that looks like this? No. Like, we're going to use a calculator to do it. And then we're going to round to 3 decimal places. You can't do a log base? I don't know. I don't know if this calculator on here has log base. I'll look. Okay. So math, go down pretty far. Oh, yep, this one does have log base. So I can do log base, and then you put the 6 in, and then you go over to x minus 1. And we hit graph. Showing part of it. We know, based on what we talked about before, that there are vertical asymptotes for logarithms. So this one is actually, the graph is showing part of it, but it has a vertical asymptote at 1. All right, think about what's making the log of 0. 0 is bad, that's log of. So it's getting closer and closer to 1. So it's a graph that looks like this. It's not showing up super well on your calculator, but that's what it is. All right, and then we want to find when it's equal to, what was it, x? Put it over here. So for y2, I'm going to put in that other function. So I'm going to do x squared minus 10x plus 23. I'm going to hit graph. Okay, so I have a parabola, and it's intersecting the log equation. How many solutions does this equation have? 2. Yeah, it's 2. There's 2 places where we're intersecting. So we're going to do second, trace, and we're going to find the intersection point, number 5. So I'm going to go over along the first curve, and I'm going to go exactly to where I think the intersection point is, and I hit enter. And then as I'm moving right and left, I'm tracing along the second curve, and I go right to where I think the intersection is and hit enter, and then I do it again for guess. Oh, really? Maybe check your signs on it. Check to see that you didn't do plus 10x, you did minus 10x. Okay, so we end up getting 3.421. So that's our first one. So 3.421. Round to 3 decimal places. All right, then we need to find the other one. So we're going to do second, trace, and we're going to go along the, so option 5, and we're going to go along the first curve and go to that second place. hit enter, and then go along that other curve to where you think the intersection point is, hit enter, and then enter again. So the other one is 6.724. Okay, so we have just solved that really weird equation. Okay? So the last one.